So we're now going to take a look at the output of this thing on a voltmeter. Begin by pointing out that I know that it will be alternating current, so the colors of these cables, of these alligator clips, really doesn't matter, and they don't correspond really to being positive or negative. But I'll put this on here, this one, so, and I will attach this one here. Okay, and again, this is our AC generator, and watch the effect now as I rotate the coil. Very difficult to see. Only a very small deflection on this meter. Let me show you again. A little bit up close here. Not very impressive at all. In fact, oh, there we go. A little bit of speed is what I needed. The meter is slightly uncalibrated. That matters too much, but we see that it is an alternating current. If I go really slowly, the effect is minimal because it is the rate of change of flux that matters, one of the factors here, right? If I speed it up a little bit, we start to see effect a little stronger, but if I go too fast, it's not like it builds up a higher voltage. It's still averaging about 0. Why? Because the current is fluctuating back and forth faster than the meter can actually resonate with, or it can't respond to. The inertia of the dial prevents it from flipping back and forth fast enough. And so what it ends up showing is an average. And the average is pretty close to 0. Okay? Now we see that quite clearly there. Now, just for fun for a moment, what I'm also going to do here is I'm going to switch part of this generator to make it DC by going from slip rings to a split ring commutator. Basically, what we're going to do now is move these contact points over to the middle section, where now every half turn this end of the coil will alternate between contacting this ring or that one, so that just as the direction of the EMF switches, so will the contact point switch, and always therefore maintaining the same polarity of that contact right here. So if this one, for example, is positive, then as the coil flips over, it's about to become negative, but now we've switched it to the other end of the coil right there at that point of contact, where that little separation occurs. Okay, so let's take a look and see what the effect of that is on our meter. Notice that I am able to get a large deflection of the dial now, and generate clearly a large voltage. Well, maybe 1 volt. Alright, and so that's how we can make DC, starting with essentially is an AC kind of effect. The alternating EMF at the ends of the coil is fundamental. And then how we pick that off of the contact points, turning it into a sort of DC effect, direct current, so that this one always becomes positive and that one always becomes negative. Now, we'll go back in the next video and take a look at some more specific details about alternating current.